here. Come on. Let's see. Hello, hello. All right, I see people coming in, so word's out. Just give people a few minutes to get here. So let me open up the textbook. All right, everybody. Just as usual, if you can participate in the chat, please send me an email at the fcps.edu email. I'm monitoring that as we go. So if you have questions, you can email me through there. So I guess first things I'd like to do is go over any questions you've had on the mechanisms problem set. Hopefully you read about the reaction mechanisms. Hopefully you have a okay understanding on it, and I'd like to answer questions as we go with that. So you had the problems, I posted the key, so hopefully you check that out. I also pulled up a couple practice problems, multiple choice problems, but I just want to go over some concepts just because they have some mechanisms already prepared, so I don't have to sit there and think about different reaction mechanisms to show you, so that are on your AP classroom, okay? And then also, so after we go over and answer all your questions about the reaction mechanism problems and we do some practice, I want to talk about what's going to be going on moving forward. It's not going to happen until the 14th, but on April 3rd, we should be expecting to hear from College Board on what the AP exam is going to look like for you a little bit better. And we've been given the okay by College Board to assign you the secure free response practice that they've posted on College Board without the secure browser. So you'll be able to do that. I still can't post the secure multiple choice problems, but that's not a big deal because your AP exam isn't going to be multiple choice. And your kind of optional final exam is only going to be free response as well. So let's get into it. Let's go. Are there any questions? Okay, so the first thing was, we had the problem set, the reaction mechanism problem set. Hopefully you went over the key. I think I emailed it out to you. Are there any of those problems you want to go over or have a better explanation of? And while I'm waiting, let me open up a new Word document as well. I think I just got an email, so I'll check that out. All right, let's do this. Okay. All right. So I did get an email. So let's see. How do you determine the speed of the elementary reactions based on the rate law and vice versa? Okay, so it's really how do you determine the rate determining step? So hi, Kate, you can be here if you want to. I'm going to go live for you guys at 1:15 for honors. This probably, especially this certain topic, probably won't help you in honors. So unless you're interested in AP, you don't have to be here, but feel free to stay. But I'm going to be doing the honors live stream at 1:15. Okay. All right. So how do you determine the rate determining step, or how do you know which steps are slow and which steps are fast? Okay. If you're given the mechanism and you want to find the rate law, you have to be told what the rate determining step is. So the rate determining step is always the slowest step. if you're given the rate law and you have to figure out the rate determining step, you can also go back and forth. But you can either, from the reaction mechanism, get the rate law, but that's only if you know the rate determining step, or if you know the steps of the reaction mechanism and you know what the rate law is, then you can determine which step in the reaction mechanism is the slowest step, which one is the rate determining step. Okay, so let me see if I have an example. So let me go to one of these practice problems here that I pulled up because I have a sample mechanism. Okay, so let me find one that we'll go over. Okay, let me just find a question. Okay, so let's look at this. Let's look at this question. Okay, so this is the overall reaction here. Okay, and this is the proposed mechanism. Now they're telling us which one's the slow step and which step's the fast step. So they tell us which one is fast and which one's slow. Remember, the rate determining step is whatever one is the slowest step. I've seen some practice problems where they'll write slow and then very slow. And then you have to know that very slow is slower than slow. And, so to find the rate determining step, the RDS, you want to go to your slowest step. Okay. So if you're given a full mechanism, the full mechanism also tells you which one is the rate determining step. Okay. Now let's go from the mechanism, and we've been told what the rate determining step is, and let's figure out what the rate law is. And let me try to walk you through how to do that. Okay. So what you do, okay, so kind of a shortcut here, is you take your reaction mechanism, you go to the rate determining step, and you use that step and any step before it in the mechanism. Not any step after, but any step before it in the mechanism. You use those steps, the rate determining steps, so the slowest step, and any of the steps beforehand, and you just count how many times a reactant particle shows up in a collision, or how many times it's involved in a step. And the number of times the reactant is involved in a step is its order. So if it's only involved once, then it's first order. If it's involved twice, then it's second order. If it's not involved in the rate determining step or any step above it, if the reactant only happens in steps after the rate determining step, then that means that reactant is zero order. Okay? So what you do is you go to your mechanism. Okay, this is the slowest step. There's no steps above it. And you say, oh, NO was involved in two NO particles were involved in the rate determining step and every step above it. So the right answer for this question is A. Okay, choice A is the right answer. And the reason why choice A is the right answer is because the way the reaction mechanism is written shows that NO is second order because it shows up twice in the rate determining step and anything before it. And it shows oxygen is zero order because it doesn't show up any times until after the rate determining step. And if it only shows up after the rate determining step, then it's not part, it's zero ordered, so it's not part of the rate law. Okay, does that make sense? Now, if this step had been the slow step, okay, let's say this was the slow step and this step right here was the fast step, then this would be the answer. Okay, why would that be the answer? Because if this is the slow step, you go to your slow step and you count how many times a reactant shows up. And notice I'm saying the word reactant, and it would be reactant or catalyst. Okay, well, oxygen only shows up once. Okay, so it's first order, and NO shows up twice, so it's second order. Okay, so because this is the slow step, this is the rate law. But if this had been the slow step, that would have been the rate law. Okay. So now let's think about it the other way around. What if they said this is the proposed mechanism, but they didn't tell us slow or fast here? They didn't tell us that. But they said, here is the mechanism. Here are the elementary steps for the mechanism. Here's the rate law. Which one is the rate determining step? Well, you would have to say, well, if this is the rate law, then the first step has to be the slowest step. And that means the second step has to be faster. Okay. But if this were the rate law, then you would know that this would have to be the slowest step, because if the first step's the slowest step, then this is what your rate law has to be. If the second step is the slowest step, then this is what your rate law has to be. So understand, like, you could just be given the steps and then shown what the rate law is, and then from that figure out which one has to be the slowest step to give you that correct rate law. Or if they give you the full mechanism, which means it also tells you which one is the RDS, which one is the rate determining step, you would use that to figure out the mechanism. Okay. So again, that right answer is A. So I hope that answers your question. But let's, while we're at it, let's go over a couple things, right? Understand, an intermediate is never used in a rate law, and an intermediate is something that's not in the overall reaction. So notice, or it's not a reactant. Okay. So the only thing that gets used in a rate law are the only thing that gets used in a rate law are reactants or catalysts, and this one doesn't have a catalyst. Okay, and I think this overall reaction is wrong because N2O2 should cancel out, and it. So, guys, this one this is from the AP classroom, but this is clearly a typo. This should say 2NO2 right here. That should say 2NO2 right there, not N2O2, because N2O2, when you add these two equations, should cancel out. So if anyone noticed that, good catch, because that's absolutely not correct. Okay? All right. So hopefully that answers your question. Let's go to the questions here. So I think that was one in your problem set that was kind of like that. So just real quick, before I get to the next question, let's, which number was that? Okay, so like if we're looking at this one, okay, 112. So the way that question worked was they gave us the mechanism, and then it said write the rate law for the first step, write the rate law for the second step if it was just elementary, right? So I did that for both of those. And then part C, identify the intermediates. That's good. D, the observed. Okay, so if you look at D for this one, D tells you that the actual rate law. So they actually give you the rate law. They say rate equals K times the concentration of NO squared times the concentration of H2. Okay, raised to the first power. So they're telling you that the actual mechanism needs to show NO as second order and H2 as first order. And so because they gave you that information, they said that's the rate law, then that means the second step is the slowest step, because if the first step were the slowest step, then this would be what the rate law of the overall reaction is, right? Because you would use that step and any previous steps to figure out the number of times they collide, which is really what reactant order is, the number of times they collide before and including the rate determining step, okay? But because that's not the rate law, right? Because that's not the rate law, it's actually the combined rate law of these two. That must mean that the rate determining step is the second step, because hydrogen shows up once and NO shows up twice before and including the rate determining step. Okay, so hopefully that answers that question. Okay, all right. Okay, let's go back to this one. Okay, so why, if this is the rate determining step, why, if this is the rate determining step, if this were the slow step, why would this be the right answer? Okay, so follow me, and I'm gonna let me try to write it out. Okay, so we got, all right. So let's do this. Let's see. Will that copy and paste? Let's see. I don't know if it will. I kind of. Okay. Hey, great. Okay, so it worked. All right. So let me. So here are my two steps. Okay. So let's talk about how we take a reaction mechanism and we find the rate law. Okay. So one way to think of reactant order is the number of times a single molecule of a reactant or a catalyst, if it's a catalyzed reaction, right? You can look at this and know that this is the uncatalyzed reaction because there is no catalyst in the mechanism. All right. But anyway, let's go back. Okay, so what you would do is if I want to find, so the first thing is know what your reactants are and know what your catalyst is. So you'd have to write the overall reaction. So you'll notice that these two guys cancel out. Straight through, okay? And so that's your intermediate. N2O2 is your intermediate. And you're left with two NOs plus an O2 yields 2NO2, right? So that's the overall reaction. So these are your reactants, right? So that's the overall reaction. Those are your two reactants. So you want to come up with a rate law. So you're thinking rate equals K times the concentration of the first reactant and then raised to X. You don't know what the reactant order is yet. You got to figure that out, and then raised to Y. So your goal is to figure out the reactant orders, right? You have to figure out, is that 0, 1, or 2? Is Y 0, 1, or 2, right? Those are the possibilities. A reactant can be zero ordered, so it's not included in the rate law. It can be first ordered, so that exponent ends up being 1, or it can be second ordered, so that exponent ends up being 2. Okay? So this is what you do. If you're given the mechanism, so one way is to use the data, which we did last time. Remember, we took the data and said, oh, we doubled the concentration and the rate also doubled, so it's first order. Or we tripled the concentration and the rate was multiplied by 9, so it's second order, right? That's taking lab data. The other way you can do it is if you know what the reaction mechanism is. Okay, so what you do is, another way to think about reactant order is it's the number of times that each of those molecules have to collide before and including the rate determining step of the reaction, not anything after the rate determining step. Okay? So what you do is you say, okay, here's my mechanism, right? And it could be 2 steps, it could be 3 steps, it could be 4 steps, whatever. You find the rate determining step. So we found the rate determining step, right? It's always the slowest step. And you say, I'm going to use this step and any step above it. Now, because this question doesn't have any steps before the rate determining step, you don't have to worry about it. So that's the only step you look at. And you just count how many times how many of the molecules of a reactant are involved in a collision. Well, the first collision involves 2 of these molecules, right? And so that's why it's 2. All right. It collides 2 times. And oxygen, which is a reactant, it's not involved. It's not involved in this step or any step before it. So that means oxygen is 0 order based on that. So because anything raised to the 0 is 1, you don't have to include it in the rate law. Okay. But now let's flip it. Okay. Let's flip it. Okay. What if this said fast and this said slow? Okay. Well, now you use this step and any step before it, which includes this step here. Well, how many times does oxygen show up? Once. So oxygen is first order. Well, how many times is an NO molecule showing up? Twice, one here and one here. So it's second order. So that would be the rate law if this were the slowest step. Okay. I hope that answered your question a little bit better. Again, I got an email question too. Hold on. Let me see if I can get back to the chat here. Okay. So Caitlin, let me know if I hope that answers your question for that one. Let's see, another question. So 14.77C and okay, so 14.77C. Let's see what that one is. Okay, we have my book out here. Okay. If the first step is the slow step and the second one is fast, which rate law do you expect to be observed for the overall reaction? Okay, so let me go ahead and type this one up here. Okay, all right. So if you look at the two steps, okay, so this is kind of what we've been talking about. All right, so they say H2 plus ICL yields HI plus HCl. Okay, HI plus ICl yields I2 plus HCl. So they gave us the elementary steps for the reaction, okay? But we don't know which one's fast and which one's slow, okay? Yet, okay? So first off, let's understand, let's call out some things, okay? Let's highlight HI, okay? Let's be able to identify HI as intermediates, okay? And so they cancel out, but they cancel out this way. They cancel out on this diagonal, which means they're intermediates. If anything cancels out this way, it would be a catalyst. Okay, and we can talk about the difference between an intermediate and a catalyst and a mechanism. Now, notice if your reaction is multiple steps, right? If your reaction is multiple steps, more than one step, if your reaction mechanism is more than one step, then you'll always have at least one intermediate. Okay, but if but you don't always have a catalyst, right? You can have the catalyzed reaction where there is a catalyst, and that's a part of one mechanism. And then there's the uncatalyzed reaction, which doesn't involve a catalyst, and that would be a different reaction mechanism, right? What does a catalyst do? It lowers the activation energy. It provides a different lower energy pathway for the reaction to occur. So there's the catalyzed mechanism for a reaction, and then there's an uncatalyzed reaction for a mechanism, for any reaction, okay? So this would be an uncatalyzed one because I know based on the reaction mechanism, there is no catalyst. There's only this one intermediate. Okay, so they told us in part C, they told us that if the first step was slow, so this is the slow step, which means this is the RDS. So how do I figure out the rate law? I use this step and every step above it. Well, there's no steps above it. And I figure out my rate law. So I would say rate equals K. And the first reactant that shows up is H2, and it shows up once. So it's first order. And the second reactant that shows up in that step is ICL, and it only shows up once, so it's also first order. So that would be my expected rate law, okay? So that's how you do it. Now, what if they had told you that the second step was the slow step? What if they said this was the RDS? If they had said this was the RDS and this was a fast step, then the expected rate law would be rate equals K times the concentration of H2, the first power, because it only shows up once, but now ICL, because it shows up twice, would be second order. Okay, so since that is, so if they had told us this was the rate determining step, then this would be my expected rate law. But because they told us the first step was the rate determining step, this is my expected rate law. Okay. All right, so let's go back. Okay. What else did you say? All right, Amelie, you said a couple other ones too. So 14.80. Okay, so 80B and D. Okay. And 12D. 112D. Did we just go over 112D? I think we might have. Yeah, okay. So let's go over 80B and D. So hopefully, I think these are all kind of the same kind of questions. So they're good questions, and we're just repeating a lot of stuff. That's good. Okay, so based on the experimentally determined rate law, which step is rate determining? Okay, so where is it? Okay, sorry. Okay. So again, if we go back to this, right, these are our three steps. So I have them written here. These are our three steps for the reaction mechanism, okay? But they tell us that the reaction is first order with respect to HBr and first order with respect to O2, okay? So let's go through it. Let's go through like what each, like if the first step's the rate determining step, what's the rate law? If the second step is the rate determining step, what's the rate law? And if the third step is the rate determining step, what's the rate law? Okay? So first step, if the first step's the rate determining step, then HBr shows up once, that's first order. O2 shows up once, that's first order. And so that shows HBr as first order and O2 as first order. So if the first step's the rate determining step, then HBr is first order reactant and O2 is also a first order reactant. But let's say the second step was. Well, remember, if the second step is the rate determining step, you use that step and any previous step, right, to figure out what the rate law is. Well, if that's your rate determining step, then HBr shows up twice. So HBr would be second order and oxygen would be first order. Okay? Well, that doesn't show. And then this is an impossible thing. It's not technically it's not impossible, but you won't see it on the AP exam. But if the third step was the rate determining step, then HBr would be 2 plus 2 would be fourth ordered, and oxygen would be second ordered. Okay? All right, and then D. Okay, so D. Okay, so they're asking, would this not like if like so some ways to kind of prove that this might be a mechanism that's taking place is they have the reaction going on and they analyze it and they try to figure out what types of compounds are showing up throughout the reaction process. So like, this is saying when HBr and O2 react, they form this molecule here. And what the question is saying is if the detector doesn't pick up any of that substance, would that be enough to refute the reaction mechanism? Well, we don't see that gets produced, so we're not going to say that this is a proper mechanism, right? So the key is that it doesn't always work that way is because if an intermediate is part of the faster steps of the reaction, then you might not ever detect them, right? So the intermediate gets produced in the slow step, but it gets consumed. All the intermediates get consumed in the faster steps. So because we don't know exactly how fast these are, then there's no way to know if we would actually detect them or not. As soon as they get produced, they might get consumed right off the bat. And so we might not detect it, right? Does that make sense? You would have to like really slow it down and monitor it over time. And if you did it enough times and measured it enough, if you measured it multiple times and you never got a hint of this as an intermediate, like that never shows up and that never shows up, then you might be able to, but just doing it once wouldn't be enough to determine whether that disproves the mechanism or not because they're not part of the rate determining step. Like if the second step was a rate determining step, and I know that happens slow, then odds are when you put your sample in a detector, you would pick up that signature because that reaction doesn't happen fast, so that's going to hang out in the container longer, right? And so if the second step were the rate determining step and you never noticed any HOOBr, then you could say that could be enough evidence to refute the mechanism because the HOOBr never is produced in my reaction container And since it's part of the lowest step, it should be there for some measurable amount of time and enough time for me to detect it. Okay. All right. So I hope that. Okay. Could you go over catalyst for a reaction? Yeah. Okay. So a catalyst is just okay. So here. So just by definition. Okay. This is the way you should think about catalyst versus intermediate. Okay. And then I'll show you an example. And I know I got another email with some questions I'll go over in a second. But so in intermediate, okay, oops, um, intermediate gets produced and consumed in a mechanism. A catalyst, okay, catalyst gets consumed and then produced. It's the opposite. Okay. So you know something's a catalyst, again, like this is what I'm trying to say. Like I'll give you an example of a catalyzed mechanism in a second, but how do I do it? Okay. What do I want to do? Yeah, let me do this. All right. So an intermediate would cancel out on that diagonal. Okay. It would cancel out along that diagonal. It would be on the top, on above it, it would be on the right side of the equation. Below it in the mechanism, it would be on the left side of the equation. It cancels out on that diagonal, right? A catalyst would cancel out. Whoops, that's not what I want to do. A catalyst. Whoops, let me do another one. A catalyst would cancel out on this diagonal, this way. Okay, it starts off in the as a reactant in a reaction mechanism, but then gets canceled out as a product. An intermediate starts the first time you see an intermediate is as a product in a reaction mechanism in one of the first steps, and it gets consumed in a subsequent step. Right? A catalyst is a reactant in one of the first steps, and then is a product in a subsequent step. If that makes sense. Okay. So if you recognize something as a catalyst, then you were writing your rate law, you would include a catalyst in the rate law because a catalyst does affect the rate of reaction, so it should be a part of the rate law, right? But that's only if you have a catalyzed reaction mechanism. Okay, like for instance, this reaction mechanism doesn't have a catalyst. Okay, so this is the uncatalyzed version of the reaction. Okay, let's see. Do we have a reaction mechanism that has a catalyst? Okay. Let's see. Do they have that? Yeah. Okay. So again, if we look at if we look at if you look at 113 in that chapter, you got Cl plus O3 ozone, right? Yields ClO plus O2. And another thing, like intermediates and catalysts are not in the overall reaction, right? Because they cancel out. When you add up all the elementary steps together, they cancel out. It's just how do they cancel out? Are they produced in the reaction mechanism and then consumed? That means they're intermediates. Or do they get used and then get produced? So effectively, they're unchanged, right? So notice here, right? We would call ClO would be an intermediate. Okay, so ClO is an intermediate there because it gets produced and then gets consumed. Okay, but Cl, chlorine, right here would be considered a catalyst. Okay, that's a catalyst because it gets used and then produced. It cancels out on that diagonal versus an intermediate that cancels out on that diagonal. Okay. So hopefully that answers your question there. Okay, let's go back. All right, so I got more questions here. Okay, yep, no problem. All right. All right, I had a question regarding the final exam. Will it cover everything we have learned this year or only the topics assigned by College Board? I'm not sure yet. I haven't made it. I'm going to have to make a new final exam, so I'm not sure. It'll probably just cover the topics College Board because that's really what I'm going to prepare for. All right, so we still have this unit that we're working on that's new that we haven't taught during class, and then everything else has been taught, and we just need to go back and review it. Since that's what I'm going to be focusing our class time on, that's probably what your final exam is going to be focused on. It'll be probably like like a practice AP exam. So we'll get more of a idea of when your AP exams are going to be. And remember, they said they were going to give you 2 windows, and really just depending on what you want to do, I would choose the latter window and the later window and do as much review because I'm gonna like based on what they release. Hopefully, they release some good information to us. But based on what they released on April 3rd, I'm gonna make a bunch of practice tests. Okay, and you guys can work on those, and then the final exam will be like one of those practice tests. Okay, and I'd like to give you the opportunity to take it before the actual AP exam. And again, but the final exam will be will be only, I will only put it in the grade book if it brings your grade up. After April 24th, the only thing that I can do is give you, you can do stuff, and if it brings your grade up, I can put it in, and if it brings your grade down, I don't do anything with it. So, yeah. Okay. So I'm not sure, but I'm guessing that's what it's going to be. I feel, part of me feels guilty about not having the acid-base stuff and the electrochemistry stuff on there. I gave you guys a practice test. Some of you've done it, and we went over that, and that can be just it. And yeah, it stinks that you didn't learn that material, or hopefully you learned it. But but I kind of want your grade to reflect, what you're capable of getting on the AP exam. And so the tests should reflect what's on the AP exam. Anyway, so yeah, that's probably it. It's probably going to be units. So for us, it will be our units 1 through 4, and then unit 7 will be what's covered on the final exam. Yeah, okay. Which is what's covered on the AP exam. Okay. So that's probably what's going to happen, but I'll let you guys know. I haven't made any decisions about any of that, but that's probably what it's going to be. That's what I've been thinking. Okay. Any other questions with the problem set or reaction mechanisms before we do some of the practice problems? And I don't have a lot of practice problems. I just want to show you a couple things as we go. We might not do all of them. I just wanted to show you a couple things. Any other questions before we on the problem set before we move on? Okay, and I'll keep checking just in case you have them. But let's come back to here. And so yeah, these are multiple choice problems, but I just want to go over a couple things that you might need to know. All right, so question 1. So like if we look at if we look at this, they're telling you that when we change the concentration of B, the rate of the reaction remains unchanged. So what does that mean? That means B is zero ordered. Okay, that's what that means. Knowing that means B is zero ordered, and that's it. Okay, so but what can we tell from that? Okay, so obviously A is not correct. That's saying B is first order. B is not involved in any steps of the mechanism. B is a reactant. It has to be like a reactant and a product have to be part of the elementary steps, right? So B is impossible. B is not involved in the rate determining step of the mechanism, but is involved in subsequent steps. That sounds good to me. Substance B is probably a catalyst. No, if B was a catalyst, it wouldn't be involved in the overall equation, right? And the reactant with the smallest coefficient in the balance equation generally has little, no effect. That has nothing to do with it, okay? So, like A could end up being zero ordered and B could be first ordered, and A is just not part of the rate determining step or any before steps. But that's the definition, right? What do you use? How do you figure out the reactant orders? You use the rate determining step and any previous steps. Okay? Any subsequent steps, any steps that follow the rate determining step have nothing to do with the rate. And since B has nothing to do with the rate of reaction, it's involved in only steps after the rate determining step. Okay? Right. Okay, so let me see if there's a couple other ones I wanted to go over. Okay. Here's good practice, right? Here's a reaction mechanism, and our final answer is D. So how do we know that this is the rate law based on this reaction mechanism? We would go to the rate determining step, which is this step, and count how many times each reactant particle shows up before that step and including that step. Okay, N2O2 is not is an intermediate, so that's not involved in the rate law. NO shows up twice because its coefficient's 2 there, right, in the first step, and O2 shows up once. So NO is second order and oxygen is zero order, or sorry, first order. Okay, let's see if I saw another one. Let me see another one. Okay. So here's another example, right? This is our rate determining step. So if we look at it, NOBr2 is an intermediate, okay? So that wouldn't be part of a rate law. So if you saw anything with that in the rate law, you just get rid of it, okay? NO shows up twice, once here and once here. And Br shows up once. So NO is first order and NO is second order and Br2 is first order, so it would be B, right? Okay. And again, if I'm, if I go too fast over something, just let me know. Or if you have another question. Okay. So based on the following, which of the following represents a species that is a catalyst? So they gave us a reaction mechanism, but they, gave us the particulate diagrams, right? So we just got to be careful. But we're looking for something that cancels out this way, right? Something that cancels out this way. Well, that's whatever this is. That circle is there here, and it's there, so it cancels out there and there, right? And what is that? That's chlorine, so chlorine is the catalyst. Okay. Let's look at this one. All right, so we have a reaction mechanism. Okay, we have a reaction mechanism. This is the slow step. So what does that mean? It means we don't look at this step. The last step is after the rate determining step, so we don't look at that when we're trying to figure out the rate law. We look at this step, the slowest step, and anything above it. And this is an intermediate, so it's not part of the rate law. And so you would say NO2 is first order because it shows up once, and F2 is first order because it shows up once, so the answer is A. Okay. So here we are again. Okay, we have these two reactions. This is the slow step. So this particle shows up once, that particle shows up once, so they're each first order, so your answer would be A here. Okay. This looks a lot like your problem set. I guess that's where they got the problems from. So this is the slow step. So HBr shows up once, O2 shows up once, no previous steps, and you ignore any subsequent steps. So it would be B. Okay. If this was the slowest step right here, if the second step was the slowest step, HBr would be second order. So A would be the answer if the second step was the slow step. Okay. And so notice that NO is not part of the overall reaction, and it cancels out on this diagonal. NO would therefore be a catalyst. Okay? And then this is the proposed steps for a catalyzed reaction of, okay, so the products of the overall catalyzed reactions are, so what you would have to do here is just add up the reactions together, okay? And whatever's left, whatever doesn't cancel out is on the product. So let's try to do this without writing it down. Okay, so Ce3 plus doesn't cancel out, and you add two of them, so that's a reactant. So you know that's a product. Ce3 plus is a product. But notice Mn3 plus cancels out. Mn4 plus also cancels out. And so the reactants are the Ce3 plus, manganese 2 plus cancels out, but on that diagonal, so manganese 2 plus would be a catalyst. So the two products are Ce3 plus and Ti3 plus, or it might be Tl3 plus. Okay. So the answer would be B there. Okay. Those are the products. Okay. Mn3 plus, Mn4 plus are intermediates. Mn2 plus is a catalyst. Okay. Ce4 plus is a reactant, and TL1 plus is also a reactant there. Okay? So I just wanted to kind of show you those. Hopefully that makes mechanisms make a little bit more sense to you. And really what you need to be able to do is, if given a reaction mechanism and you know which ones are the rate determining step, and the rate determining step is just the slowest one. So sometimes they might just ask you a question, which one's the rate determining step? It's just whatever the slowest one is. Okay. Given a reaction mechanism and being told which are the fast steps and the slow steps, come up with the rate law. Okay, so basically figure out the reactant orders for everything, right? And then the other way would be, hey, here are the steps for the mechanism, but I don't know which one's the rate determining step. Here is the reaction mechanism. How do I find which one is the rate determining step, right? Then also be able to define intermediate, and basically, and all you have to do for intermediate is something that gets produced and then consumed in the overall reaction mechanism, and define catalyst. Catalyst speeds up an overall reaction, provides a different pathway, but in terms of the reaction mechanism, a catalyst is something that gets used. So it starts out as a reactant, and then it gets produced and it ends up a product, but it still ends up canceling out. It's not part of the overall reaction. If it's on one side or the other, it's either a reactant or a product. If it's not included in the overall reaction, but it's part of the mechanism, it's either an intermediate or a catalyst. Okay. All right. So does the order of the reactants for the rate law matter? Like, does the order in which you put them in the rate law matter? No. If that's what, if you mean like if we go back here, like you could put H2 here and IC or ICl here, or you could switch them around. What matters is that you get the right exponent. What matters is the order of the reactant, not the order in which you put them into the rate law, if that makes sense. Okay. All right. So, okay. Are there any other questions before I just want to talk about, what's to come a little bit, and kind of what to expect when we get back on the 14th. Especially if you haven't heard from your other teachers, like there's actually like time where you have to be in class and virtually and stuff like that. So I want to let you know what I'm planning. Okay. Any other questions? Okay, so first let's just go kind of an overview here. So I'm not going to post this yet because I don't know if this is final yet, but this is what so far the school is saying we're going to do. Okay. So this is what a week is going to look like for you once we start school back up officially running on the 14th. Monday is kind of a teacher workday, and this is going to be the way it goes every week starting the 14th. So 14th is a Tuesday. So starting that 13th, we'll have our teacher workday, but every Monday after that will be kind of a teacher workday. And during that time, you'll be expected to work on any assignments and stuff that have been given to you by all your teachers. Okay. Tuesday will always be a orange day, and Thursday will always be a blue day. Wednesday and Friday will be days where the teachers will have optional office hours for you to show up at any time to ask questions or at the given time to ask questions. And it would be where you work on independently or with, your classmates virtually on projects or assignments or whatever. Okay, during that time. But Tuesdays and Thursdays will be just like school days. Okay, but they're a little bit different. So each class will meet for 45 minutes. Okay, so like if you're in my first period, like Amelie, you're in first period AP Chemistry, I will be seeing you at 9:15 on Tuesday. Okay, every Tuesday starting the 14th, right? But if you're in my second period AP Chemistry class, I'm going to see you at 9:15 every Thursday, starting what would that be? The 16th. Okay, and then eighth period AP Chemistry, I will see you every Thursday at 1:30. Okay, so this will be the time where I will implement instruction, most likely, or I might just have a chat. What I might end up doing is just posting a lesson and telling you to, watch the video on this day, or watch the video on this day, or watch the video and then come in and answer questions, and I'll answer questions. Okay, so but that'll be official times for us to meet as a whole class, right? I'll be taking attendance and we'll be monitoring things. So like, in the end, if you have a complaint about your grade, which I can understand, like, it's going to be hard to not have complaints about grades or, whatever. But, I can say, well, you didn't show up at all for the rest of the school year. So there you go. So so this will be the blueprint for every week starting on Monday, April 13th. Okay, so just kind of expect that. Like, so whatever your fifth period class is, you're going to meet with them every Tuesday from 12:15 to 1 p.m. every Tuesday starting the 14th of April. Okay, so that's kind of the way it's going to be worked out. Okay, any questions about that right now? Yeah, Caitlin, I prefer you sending it to the fcps.edu email and not the schools.net, just because that's the one I check. That's the one I check all the time. But anything you've sent to my fcpsschools.net one, like if you've shared a Google Doc with me or something, if you've gone through Google, I'm going to check that before, I haven't, the only thing I've done to the grade book right now is I've changed the percentages of weights of everything. Changed the weight of first quarter, changed the weight of second quarter, changed the weight of third quarter, and changed the weight of your final exam. Okay, fourth quarter doesn't count at all because it's a no mark. Okay, so that's the only thing I've changed in the grade book. If you've done test corrections, I have them. I have them saved, and I'm going to go through them, and I'm going to adjust those scores appropriately as coming up here soon. But you can email me either way. But if you have a question that you want me to get back to, I'm not going to check my fcpsschools.net email, probably not for another week or so. I just don't care about that email. So fcps.edu, if you have a question, okay? So I think they built into the schedule, so advisory, they've built into the schedule that advisory teachers can still meet with their kids, because they're concerned about the teachers and the kids that have developed strong relationships with their advisory class. My advisory class is all freshmen this year. I haven't really developed a strong relationship with them. Kind of ignored them. We've done our lessons and stuff. But fourth period will be for advisory. And so I'm guessing this won't be a thing anymore. This was kind of like, this is the county blueprint. And that's why I didn't want to publish this. West Springfield might tweak this a little bit. This is when we have to meet, right? But what might end up happening is maybe it'll just say 268 for West Springfield. This is like a county-wide thing for high school. But I'm guessing that might change unless advisory teachers really want to meet with their advisory students. I don't foresee that happening. But you juniors and seniors, you might really like your advisory teacher and you might want to talk to them. But that's really what that'll be for. Okay. It hasn't really been addressed to us yet. Okay. Okay, no, we're not going to meet using Zoom. We're going to meet using Blackboard Collaborate. And that brings me kind of my next thing. I do want to meet again on Thursday this week at our normal time around 10 o'clock. But we're going to be using, instead of live streaming on YouTube, we're going to be doing Blackboard Collaborate. So I'll post a link in Blackboard and I'll email the link. And it's kind of like Zoom. It's kind of like a Zoom meeting room, but it's the thing the county wants us to use. And you'll be able to talk to me. And if you want to, you can use your camera and show. But I can also record the lesson and post it on Blackboard and stuff like that. So that's what we're going to be meeting on from now on, is Blackboard Collaborate. But I'll post the link on Blackboard and I'll email it out to you guys. It's kind of like Zoom, but they don't want us to use Zoom officially because apparently there's been some security issues with Zoom. They want us to use Blackboard Collaborate Ultra, and that's what we're going to be using. And it's a lot like Zoom. So something that's like Zoom, so a virtual meeting spot. So it won't be live stream where all you have is chat capabilities or sending me email. You'll actually be able to talk to me using your microphone and your camera if you want to. Okay. And we'll be able to meet there as a class. So that's how we're going to be meeting as a class. Like, so for, second period on Thursdays at 9:15, you're all going to go into Blackboard Collaborate. You'll be able to say hi to all your classmates and stuff and be able to ask questions. Like, there's a raise your hand function and stuff, like if you have questions for me and things like that. So it's pretty neat. We've been working with that over the couple of getting to learn that software a little bit for the past couple of days. So that's what we're going to be doing. It's a lot like Zoom, though. Okay. All right. So, but I'm going to be available more than that, and I'm going to be posting more than that. But if you didn't see this, I've posted this and I emailed it out to you. So this is really what our class is going to look like going forward, starting the 14th. Is so the first week or two will be the Unit 7 stuff, because I need to teach that as soon as possible for everybody. And it'll be Unit 7 stuff, and we'll go through it fast. And at the end, I'm going to give you, a Unit 7 take-home test. Okay, well, obviously a take-home test. I'm going to give you a Unit 7 test. And you're going to hand it back to me. And if you get a 90% or better, I'm going to put 100% test grade in your third quarter grade book. If you get 80% or better, I'm going to put a 90% test grade in your third quarter grade book. Okay? And if you don't do it, you don't do it, whatever. Again, I can't assign anything new that hurts your grade. So, take that as it is. Okay? What you might want to do is go on SIS and check out what your grade is right now based on the new weighted averages. So this is the new weighted averages. So first and second quarter are going to be the beefiest part of your overall grade because that's units 1 through 4, and that's most of the content that's going to be asked on the AP exam this year. It's going to be units 1 through 4 and then unit 7. Okay. Third quarter was when we did all our acid-base stuff and our electro and thermo stuff. And unfortunately, that's not on the AP exam. So I'm going to give you credit for doing that, but that's going to only be 10% of your grade. And I'm going to give you a final exam, which will be like a practice AP exam, but it'll be like a practice AP exam based on what the new exam is going to look like. And I'll have more details for you on that, hopefully after April 3rd. And so I'll have some practice final exams for you, which will be practice AP exams and that kind of thing. And again, that's going to be kind of an optional thing. So if you don't want to do the final exam, like let's say you're not taking the AP exam, so you don't want to do the final exam, then this is what your grade will be based off of. And your final exam will just be excused, okay? So that's what it'll look like. So you might want to see how those different percentages maybe adjusted your overall grade. Some might be for the good, some might not be for the good. So you might want to think of different ways to raise your grade. And so the other things that you're going to be doing besides Unit 7 and us practicing for the AP exam is you can do quiz retakes. Okay, so any quiz retake you want to do. But the way you have to tell me, you have to let me know 24 hours in advance, and you can take it during my office hours. So my office hours will be Wednesdays and Fridays, 8 to 9 and 12 to 1. Okay, so these will be the times where, hey, if you want to take a quiz retake, you got to let me know 24 hours in advance so I can make the quiz for you, because I'm going to make individual retakes for anyone who takes a retake. It's not going to be the same quiz. So if you retake quiz 4.2 and somebody else retakes quiz 4.2, they are not going to be the same quiz. Okay, there will be different numbers, different things. And what will end up happening is, so you'll show up to my office hours through Blackboard Collaborate at, let's say, 8 on Wednesday, and as soon as you show up, I'll say, okay, I'm emailing you the quiz, and I'll say go, and you'll have 30 minutes to take the quiz, either take pictures of your work or scan it in and send it back to me. And if it takes more than that, then you don't get credit for it. It won't hurt your grade, but I'm not giving you credit for it. Okay, so it's going to be very yeah, I guess you could look up answers and that kind of thing. Try to collaborate with your friends and stuff like that. But if let's say it's a 15-minute quiz, I'm going to add 5 minutes for you to be able to take a picture or scan it to me and send it back. So if it's a 15-minute quiz, you got 20 minutes to get it back to me. And if I don't get it back within that 20 minutes, then it's not going to count. Okay, so that's the way that'll work if you want to retake quizzes. And you can still do your test corrections. I would focus on units 1 through 4 if you haven't done those yet, because that'll hopefully help you review for the AP exam. But obviously units 1 through 5, you can still do test corrections if you haven't done so on those to get your curve. Okay. Are there any questions with that? Okay. Do you know how fourth period was? Okay. I used Blackboard Collaborate for an online class and I had to download it, not use a browser. I don't know. Maybe your school computer already has it. All they said is the teachers have a link for our meeting room, and we send out a link to students, and you just show up. So that's what we're going to do. We're going to test that on. So what I'd like to do on Thursday is I want to test that Blackboard thing. So what I want to do is plan on meeting at 10. I'll post the link to the Blackboard Collaborate Ultra. I'll post that link on Blackboard at around 10. And what I'd like to do is I'd like to talk about integrated rate laws. So the next part of Unit 7. And so we'll talk integrated rate laws a little bit and just test the Blackboard Collaborate. And if it doesn't work, I'll end up going back to YouTube and we'll figure out what's going on. Okay? But we haven't been told that students have to download anything. All we've been told is that just send them the link. So maybe it's already on your laptops. I don't know, your school laptops. And if you don't have a school laptop, then maybe you have to download something. I don't know. But that's where we will be meeting. So we'll test that on this Thursday. Sorry, we'll test it on Thursday. Okay. So yeah, I plan on let's plan on meeting on Thursday again at 10 a.m. But this time through Blackboard. And if for some reason that's not working, we'll go back to YouTube and live stream it. Okay. Are there any questions? Questions, concerns? Okay. So let's just plan on meeting on Thursday. I'll put the link up to Blackboard Collaborate on Thursday morning, 10 p.m. or 10 a.m. Sorry, and we'll meet then, and hopefully it'll work out. And if it doesn't work out, then we will go back to YouTube for that one. Okay. All right. Thanks for showing up and good questions. Have a good rest of your day. Okay.